Today we're working on solving systems of equations, which means finding the point of intersection. When we did this in grade 9, what we would do is graph the two functions, the two equations, and we would put them in the form y equals mx plus b so it was easier to graph, and we would draw the line, and where they met would be the point of intersection. So let's do this. If I take a look at this one here, and I look at the intercept, the y-intercept is at 2. And what I'm going to do, this is the slope, which means it goes down 1, across 1, down 1, across 1, down 1, across 1, down 1, across 1. And I can just graph this and label it y equals negative x plus 2. And then I can take this one here and do the same thing, find the y-intercept. And this one here is down 2 across 1, down 2 across 1, down 2 across 1, down 2 across 1, 2 across 1. I don't have to make that many, but I want to make sure that we can find this point where the two lines will intersect. And I can label this one y is equal to negative 2x plus 6. And as you can see, our P.O.I. is right here. And if I look at my graph where that stands, if you look here, that's 1, 2, 3, 4, negative 1, negative 2, negative 3, negative. So this point here is at P.O.I. is at 4 and negative 2. And so this way we know that these two lines intersect at this point. And if I were to plug this point into either of these equations, it would satisfy the equation. So for example, if I take the 4 here and I plug it into the x, I get y is equal to negative 2 times 4 plus 6. Y is equal to negative 8 plus 6. Y is equal to negative 2. Which is what we want. I can do the same thing here, and if I plug in y is equal to negative 4 plus 2, I also get y is equal to negative 2. And so this point satisfies both equations, and this means that at this point both equations meet. And that's how you found the point of intersection. Now I'm going to show you how you can look at the equations and find out whether you do have a point intersection or not. So let's move on to the next section. Are there P.O.I.s for every system of equations? Well, let's think about this. When will two lines not meet? Well, if the lines are parallel, they will never meet. And this would look like this. Example, y equals 3x plus 2 and y equals 3x minus 1. Both have the same slope. So, same slope. Therefore, parallel. No point of intersection. They will never meet. So that's one situation that we know by just looking at the equations, just finding out in the form of y equals mx plus b. You can just look at the slopes here, and if they are the same, then that means that both lines are parallel. And notice that the y-intercepts here are different. That is very important. Why do I say that? Because let us look at a second example. This would be example 1, and let's look at example 2. If two lines have the same slope, and the same y-intercept, then there is an infinite number of solutions. The reason for that is because they meet at every single possible point. So for example, if you had something like y equals 3x plus 2, and then you had something such that the equation was written differently. It could be written as 2y is equal to 6x plus 4. And you would say to yourself, well, we want to put this in y equals mx plus b, and therefore we need to isolate for y. And so what you would do to isolate for y would divide everything by 2. And by doing that, what do you see? You would notice that y is equal to 3x plus 2. And therefore this equation and this equation have the same slopes and the same y-intercept, and therefore there is an infinite number of solutions. And finally, our third situation would be if two lines have different slopes and different y-intercepts, then there is only one solution, one POI. And so if we had, for example, anything, you can take anything. Y equals 3x minus 2, y equals negative 2x plus 4. The slopes are different, the y-intercepts are different, therefore one POI. And there you have it. And that's how you can figure out, just by looking at the equations, whether or not you have a point of intersection. Now we're going to try and solve the point of intersection.